everyone, hope you all are well. In today's video we will discuss one of the most important topic of thermodynamics, which is Hess law. It is basically related to solve the numericals related to thermochemistry. Now let's begin. Hess law. It states that total amount of heat absorbed or evolved in a reaction is same whether the reaction take place in single step or number of steps. This Hess law states that the amount of enthalpy change means either the heat is evolved or the heat is absorbed. It will be same during the reaction. Either that reaction will take place in single step or that reaction will take place in multiple steps. The enthalpy change will remain same. Let us consider an example. See, here carbon reacts with oxygen molecule and it will form carbon dioxide. The enthalpy change for this reaction is this minus 393.5. So this is the enthalpy change when the reaction takes place in single step. Now if we take this similar reaction in two steps, then we have to check this enthalpy change of a reaction will same or not. Now see, in the first step carbon will react with half molecule of oxygen, means one oxygen, and it will form carbon monoxide in the first step. And enthalpy of reaction for this is minus 110.5. Next step, this carbon monoxide now acts as a reactant and it will react again with half molecule of oxygen, means one oxygen, and it will form CO2. So we get CO2 from here and CO2 from here. So the enthalpy of this reaction is this. So if we talk about multiple step reactions, then we have, this is not the enthalpy of complete reaction. This is the enthalpy of this step of the reaction. And this is the enthalpy change of this step of the reaction. Now if we want to calculate the complete enthalpy of reaction, then what we have to do, enthalpy of reaction will be equals to H1 plus H2. Now put the values 110.5 plus minus 283.0. On solving, what you get, minus 110.5 plus minus minus 283.0. On solving, what you get, 0.539 minus 393.5 kilojoule per mole, which is similar to the enthalpy change during the reaction when we did this reaction in single step. So Hess law is verified that amount of heat absorbed or evolved is same whether the reaction take place in single step or in multi-step. This is Hess law. Now consider the theoretical proof of this Hess law. For this we will consider a reaction from A to D. If this A directly converted to D, then Q amount of heat is evolved out. And if we talk about this reaction in number of steps, first A will convert it to B, Q1 amount of heat is evolved, B to C, Q2 amount of heat is evolved, and C to D, Q3 amount of heat is evolved. On adding, the total heat evolved is Q1 plus Q2 plus Q3, which is Q dash. So we will apply Hess law. We have already studied in Hess law that either the reaction occurs in single step or it takes place in multiple steps. The enthalpy change will remain same. So according to Hess law, this heat evolved and this heat evolved should be same. So according to Hess law, Q is equals to Q dash. But if we talk about that Hess law is not applied here, then there will be two situations. Either Q is greater than Q dash, means this much amount of heat is greater than this heat, or this much heat is greater than this heat. Now if we consider Q dash is greater than Q, this means heat evolved A to D steps during the A to D formation. the when occurring multiple steps means A to D, heat evolved is greater than, means this Q dash is greater than heat absorbed when changes from D to A directly. This line means this is greater than this, means heat evolved when changes from A to D, not directly A to B, B to C, C to D. Then this Q dash is greater than the amount of heat absorbed, which is directly from D to A. So if we consider this aspect, according to this, some heat is created during the number of reaction. Means when number of steps were followed, then some amount of heat is created during the reaction. As we already studied law of conservation of energy, that energy can neither be created nor be destroyed during any chemical reaction. Heat is also a form of energy. So we can say that this is against the law of conservation of energy. So Hess law will only be applied only and only condition when Q is equals to Q dash, means amount of heat absorbed or evolved in a single step or in multiple steps will be same. This is all about Hess law. Now we will discuss certain applications of Hess law. Let's continue further with the applications of Hess law. In this, I summarize the applications of Hess law. We will discuss each and every application in our numerical portion in the next video. So, I summarize the applications of Hess law. Calculate enthalpy of formation. If we talk about the formation of any compound, for example, carbon plus oxygen, CO2. If we talk about this is the direct reaction. As in previous video, I have write this reaction in multiple steps. So with the help of Hess law, we can calculate the formation of carbon dioxide in multiple steps. So it is the enthalpy of formation. Second, calculate the enthalpy of allotropic transformation. Allotropic transformation means when carbon in its graphite form changes to carbon in its diamond form. Next, calculate enthalpy of hydration. When we add water to certain substance, its enthalpy change we can calculate by Hess law. Calculate bond dissociation energy. Bond dissociation energy is what? When we break any bond in the molecule. For example, if we talk about H2 plus Cl2, it will form HCl. How it will be formed? Here the bond present between H, this hydrogen bond will break, this chlorine bond will break, then will form HCl. So the amount of energy which is required to break this hydrogen bond and this chlorine bond, that is called bond dissociation energy. So with this we can calculate bond dissociation energy also. Next, calculate enthalpy change of the reaction. During a reaction, is there any enthalpy change? We can also calculate that with the help of Hess law. We will discuss bond enthalpy, which is of two types, bond formation or second is bond dissociation. Bond dissociation. Bond formation means whenever any elements combine to form a molecule and there is the formation of new bonds, then the amount of energy released is called bond formation. Amount of energy released during the bond formation. For example, this is one element and this is other element. Here we form CO2. So basically in this reaction there is a bond formed between carbon and oxygen. So if the bond is formed between carbon and oxygen, so there is some amount of energy released In the previous reaction, we have written the energy change, which is negative. So wherever the energy is released, then it is negative. So the bond enthalpy means energy change during the bond formation is always negative. Now if we talk about bond dissociation. Bond dissociation is the breaking of bond. For example, if we break hydrogen and chlorine and form HCl bond, the amount of heat absorbed for the breaking of bond, we have to put some energy. If we want to join anything, we don't need much energy. But if we want to break something, we have to put more energy. So we need more energy. So energy is absorbed. If energy is absorbed, then delta H is equals to positive. So this is all about thermodynamics. With this, our thermodynamics chapter will be covered. Now, in the next video, we will discuss some numerical problems. That's all for today. Thank you and have a nice day.